Hey guys, this is Binary Fission. I wanted to talk a little bit about using state machines for enemy AI and my experience in transitioning over from the way my old code was constructed. When I first made a prototype of a game that would eventually become Tower of the Immortals back in 2018, I did not have any idea as to what state machines were. I had a rough idea of different states that AI would occupy, but it never really occurred to me at the time how to look up a more efficient way of doing it. At the time, I was focused on learning how to make any kind of game at all. This was my first experience with game development, and my coding skills were extremely rudimentary. While I did get the AI to work in the end, the result was a really ugly and bloated mess that was hard to follow and even harder to debug. When I began to work on Tower of the Immortals several years later, I knew that I couldn't continue the bad coding practices of the past. If you're familiar with what state machines are simply algorithms that read a set of inputs and change to a different state based upon those inputs. From this model, the flow of logic can be constructed such that enemies respond to certain inputs in a predictable way. Each state represents a single finite block of code that contains its own behavior independent of other states. This makes code easier to organize, debug, and change. The first boss of the game is the same boss I created for the prototype, albeit with a few changes and modifications. When I first began development of Tower of the Immortals, I placed my old boss in a room with 0 modifications just so that the game would actually have a boss. As I continued to refine my programming skill and implement proper design patterns, the task of changing the mess of code that was this boss's AI loomed over my head. Just before releasing the final demo build in early July 2024, I decided to finally bite the bullet and make these long-needed changes. This was partially because I needed to make some changes to how the boss reacted to the player, but also because I needed the option of extending her moveset for the future if the need arose. I could also use the overall structure of the code as a guide for future enemies and bosses. And the old code was really bad. There were so many unnecessary variables and checks all over the place, and no clear sense of when the boss existed in one state or another. Because I wasn't using a state machine, there were cases where the boss would wind up executing multiple sets of instructions simultaneously if the fight went on long enough. This didn't come up often in playtesting, but it was noted by a couple of players. I spent the next couple of days completely rewriting the code and tearing out the logic I had written so long ago. Because of how the logic worked, I couldn't really test it until it was done, but the result was that the code size shrunk by about 40%, a substantial number of variables were eliminated, and the code ran even better than before. I also made a few other improvements, such as using a shader on the spells cast to give each attack its proper color coding instead of using separate sprites for each. I also passed these states into a single object that would then execute the spell or attack associated with that state. The old code had separate objects for each, fragmenting the logic and making it more difficult to debug and change. I also condensed several code blocks into object methods, usually logic that was repeated multiple times throughout the code. This AI isn't perfect and there are still a few variables and inefficiencies that can be eliminated, but it's far better than before. Actually implementing the state machine was quite simple. I made use of enums, which are a data type that has a list of constant values that can be named. You create a value for each state you want your enemy to have, and then you set your state variable to the value corresponding with that state. You can also accomplish this with macros, but the advantage of using enums is that you don't run into namespace conflicts whenever you use the same names for constants in different enums. Remember that enums are considered global in scope. Refactoring this boss AI was a really good way to practice using state machines, but it was also a good way to practice writing cleaner, maintainable code that would be much easier to change and modify in the future. While there are other ways of writing AI, state machines are a battle-tested method that is relatively simple for newer programmers to pick up, while still being powerful and flexible in the hands of experienced programmers. The nice part about state machines is that whenever you encapsulate your code within a specific state, you can focus entirely on just the code within that state whenever you want to make a change or fix a bug. While code within that state can affect transitions to other states, it should not depend upon the execution of code in another state, since only code from one state should be executed at a time. If you're interested in learning how to use state machines, there are lots of great resources that will give you more information. I've included a couple of links in the description in the video below. Thanks for watching, and if you're interested in following development of Tower of the Immortals, I've included a link to the itch page, as well as a link to the Discord server. I'll see you guys in the next video.